So my name is Aaswad Kulkarni. I come from a varied experience within the industry, and I'll tell you at the end why I am referring to it. So I've done a bit of telecom, robotics, oil and gas, locomotive, and finally into automotive. Like I said, the reference to it I'll touch upon when I come to the end of the presentation. So the idea of what I'm going to talk about essentially is, we've talked a lot about SDV. So what I'm going to do is jump directly into an architecture aspect of it, how we see it shaping up today. Yesterday we saw a lot of presentations, especially from Robert, on the SOFI aspect of it and how the containers are a possibility that are going to come into the automotive embedded realm. And he had one nice slide where at least it showed classic and adaptive in one of the slides, and containers shown together. So what are the aspects? Why is the industry going towards it? What is the need? What may be the benefits? And then how adaptive autos are very specifically structured? What's the architecture? I was talking to Martin earlier to see if he had looked at my presentation. So what are the advantages where adaptive AutoSAR is already good at, and how it could be extended from a containerization perspective? And what I think is the limitation, it may be a strong word, but what I see is a limitation, and how we can expand it. And the proposal is essentially, there are possibilities to expand it such that when containerization or containers on our ECUs, obviously the HPCs, becomes a common theme, how adaptive directly fits into it. Because the whole idea is to have a standard middleware and extend it to adopt the newer architectures, if you will. So this was the, anyway, I'll just talk to it. So this is a very generic view of the architecture. On the left side is what we typically see. You have OS and you have directly a middleware, and there would be applications. And I have not shown I'm not shown multiple VMs here just to keep the slide very simple. But the point being, there can be VMs, but there still be an operating system, there will be middleware and applications on top. What you see on the right side is essentially what is mimicking what Robert showed yesterday, of container runtimes and then containers and then applications running within it. So what's the implication of this architecture? So where are we going when it regards to the containerization aspects is, it's a relatively new thing within automotive. Again, referring back to SOFI presentation yesterday, we've looked at the cloud native paradigm, everything being built in the cloud, microservices, the architecture being proven, the features being proven early in a cloud environment, and then being pushed down. So if we are doing that in a containerized way in the cloud, why not bring it down to the embedded world itself? That's where the whole movement is. So if you have a microservice, you have granularized it, you have implemented the feature to the right content, now bring it as is to the embedded world, which is essentially what SOFI is focusing on. That was the whole point, which is why the containerization is coming. So frequent updates, faster time to market, flexibility, portability. Another aspect of, maybe you would have seen a meme that usually goes around. A developer says, it works on my machine, and the other guy says, okay, give me your machine. And that's how containers were born. Because essentially what container says is, you encapsulate everything that is with the right dependency, and you push it in one encapsulated block. And you have the application, you have the dependencies, everything built in. All it needs is an operating system, obviously underlying, because the runtime focuses on the operating system. So that's essentially the piece why it came up. So we have talked of earlier presentation as well. Classic has been on C. We are talking on C++. Rust has been coming in. So think of a scenario where you can have a C++ based implementation with its library dependencies and a Rust based implementation with its dependencies. And you don't really need to bundle the whole thing together. You can have it in individual containers with just their right dependencies and have it deployed. So that's the flexibility this kind of architecture is going to bring. So with that perspective, what is adaptive saying? So at the bottom, it calls out virtual machine, container, or hardware. And in the adaptive session as well, Martin and Nadeem were also mentioning that it was always focused on being in a particular machine. So what we are saying is, any relevant clusters that are needed, all packaged together, being a part of a particular container itself. So the whole thing runs on a VM, the whole thing can run in a container, and that essentially is going to lead to a lot of bloating in very simple terms, because the second bullet point there on the top is it's forcing the implication that you have to have the platform running within the container, which should not be the limitation. I know it doesn't mean every single cluster has to run. We can pick and choose what is the right need. But the point is when you're going from a design paradigm of microservices, you're trying to narrow it down. A platform shouldn't be a dependency such that a container image is going to be huge and take care of the entire middleware coming along with it. So that's kind of the my perspective on where we are moving from containers and where adaptive needs to come together somewhere in the middle. Now to bring that in the middle, as soon as we say containers, usually the immediate dependency is Linux, because that's where the container runtimes today are available and the containers will run on it. But since finally POSIX, maybe other operating systems will go there. I think Qualcomm in the morning talked about Safe Linux. So there are flavors coming in of other parts of Linux as well, which may not be, by default, it may not be currently a real-time need or a safety certified one, but we have those flavors coming in. So directly, a container runtime mapped on, let's say, a Safe Linux will become a possibility. What I'm going to propose essentially is how we can relook at the adaptive AUTOSAR structure, the architecture, and try to expand it, not fundamentally change it, how to expand it to bring about, take in the need for containers and take in the need for lightweight implementation. So we anyway know ARA provides a good degree of portability guarantee, so that essentially continues. So what is the usual need of the containerization? What are the focuses? Adaptive anyway focuses on all the different aspects of provisioning, health, updates. I've only picked a few cases. So process management, which execution management does today, health management is handled directly, software package update is handled by UCM as well. So what are the other things we are looking at? We are looking at managing the containers, we are looking at handling their health, and we are also looking at updates of the containers. And now, interestingly, outside on the UCM placard or standee, beyond 2311, there is one bullet point which says explore the deployment of containers. I think that's one of the items that's mentioned there. So essentially, we are heading there within the near future. So the thought process is essentially, to expand these, like I said, not fundamentally change it, to expand it, to be able to handle containers. Now, this is being owned. Basic containers comes under the OCI initiative, the Open Container Initiative. SOFI is basing all the containers aspect on OCI itself. So essentially, the two parties need to come together, and yesterday they were. So that's where the expansion needs to happen. The clusters, the way they stand today, instead of being interdependent, some of them are only API based, can become service based, such as the UCM is or the state management is. So it can be expanded. So I'll go into the next slide where I'll spend more time here. So see, the thought process looking at the OCI compliant runtime from standardization. So standardization from AUTOSAR perspective, standardization from containers perspective, bring the whole topic together. So what do we need for container management? There is something called OCI runtime, already exists. What do we need for process management? Execution management already exists. Only thing it does is it is within the machine, it is within the virtual machine. As is, it will be only within the container and it will manage only the life cycle. So what do we need is the overall life cycle management. Now, when I say overall, means container life cycle as well as the process life cycle. So process life cycle already exists. But can we enhance execution management, for example, to bring in the handling of the OCI, the containers as well? And the OCI runtime specification already gives that flexibility. There is a possibility of implementing the hooks within the runtime specification, utilizing the runtime specification, and we can have execution management expanded to handle the life cycle of the containers themselves. And as long as it is OCI compliant, it is a straightforward thing to be implemented. So that's where I've called out something called as an EM master. So When we set a container runtime and things running within the container, so process has its life cycle. Container runtime is managing the life cycle, but there needs a governing entity which is going to manage everything together. And that's where an EM master kind of thing can come, where the way UCM master and UCM clients has APIs, service interfaces rather, which talk to each other. The similar concept can be extended to have the container lifecycle and the process lifecycle, because within a container there will be very few processes per se. So that's where the aspect of expanding the whole architecture can come in, and we can have the whole lifecycle managed. Another angle which comes in is usually the data access and storage. So the persistency currently as a library is defined in the standard, and that's a good enough way to proceed as well, because each process has to own its own data, has to own its own file system, and it will have the right dependency together. So from that perspective, sorry, just taking a check on time. We have the persistency library as is can be expanded. Lastly, what comes is software updates. Now, we already have the UCM master concept. There is UCM client. It can also talk to classic AutoSAR. All of that is fine. So that runs on its own. Now, the another aspect of it is we have it running within its own container itself. So it provides a complete functionality on its own, running as a separate container. Because it has service interfaces, it can talk to any other UCM client or any other entity which is supporting those service interfaces or which is subscribing to those service interfaces, and you can easily expand the implementation there. So what that helps is the update of the cluster itself, as well as the update of, anyway, the processes was already there. Again, the OCI specification also provides the specification to have the images, how the images should be built, what is called as a file system bundle as per the OCI specification. So if that is supported, and that I assume will be the way going forward of that bullet point as I was mentioning that I saw outside, with regards to having container images deployed and not just software packages which are limited to manifests and binaries and libraries and so on. So that would be the expansion of the software update philosophy to have not only the software packages, but also have the file system bundle also pushed, which is the OCI compliant image to be deployed. So kind of the gist of it, I've only picked a few examples to kind of highlight the idea that we have this need going ahead, kind of, which is bringing me essential to a summary slide. So we have this need of containers coming ahead, because that's the way we will exploit what we are doing in the cloud, the best way to bring it on our HPCs directly. So that's the need that will flow in. We've talked of DevOps, we've talked of early validation, early development, so on and so forth. So why not capitalize on it and bring it into the embedded, provided as the container runtimes mature, we'll be able to bring it in. So I don't think it's far off in the future. It should be coming in soon. We should not have the overall platform as an overhead right now, pushing the whole thing into container and repeating it, because image sizes are going to increase, startup times are going to increase, and we are not really capitalizing on the fact that architecture already exists. It's just a matter of expanding it a bit. So we should derive that with all the challenges and everything that we were talking about. That makes a way forward, bringing to the last bullet point of, we have OCI, which is Linux Foundations. We have SOFI, which was talked about a lot yesterday as well. And so these entities coming together and bringing the need to have the newer architecture, the newer way of development, and a newer way of deployment. Complete this circle, bring everything together. Which kind of brings me to my closing remark with regards to the fact that, as I was saying, I have touched on different industries, and what is exciting to see is different technologies now coming together. So example, 14 years ago, I was working with a locomotive industry where we did implementation of a middleware which was service oriented. which had DDS kind of a support, and I was working on definition of XML files, which will have all their data. At that time, I did not know what AutoSAR is. Had I known there is a standard available, capitalize it on that. At that time, adaptive did not exist. But the point of standardization, the point of having this piece ready, so containerization will mature. The deployment on embedded will mature. It's still early days, but it will mature. So why not take our architecture and move it quickly towards being able to easily adopt and define it in a standardized way, so that nobody has to build custom solutions. B, nobody has to learn it all over again. And lastly, one thing which I think during the Eclipse SDV session, I think Michael was here, was mentioned as to how. So the example is how AutoSAR can take it to other industries. So around again 7 years ago, I was talking to one of the manufacturing industries, and it was just a presentation on what is AutoSAR. They were not automotive, obviously. But what resulted, a 30-minute overview resulted in a 1.5-hour discussion, was the fact that they were at that time focusing on standardizing the OPC aspect of it. So what was OLE for process control became open platform communications and OPC UI architecture. And finally, one of the directors from that company joked while leaving is that when I buy my next car, I'm going to ask if AutoSAR is in there. So because yesterday, I think Michael was joking, nobody's asking whether AutoSAR is in there. So I thought I'll just share that. So that's kind of the whole, the storyline, the thought process of standardization. Those who remember my talk last year will see a recurring theme of me trying to bring different pieces together. Last time I talked about challenges of all the different ARXMLs and IDLs and whatnot, and try to bring it in a standardized way. This is where I see industry moving, and can we address it soon so that it's standardized and easier to adopt. Thank you.